friends, welcome back to my YouTube channel. Friends, today I am going to cover network load balancer. So if you follow me, we are working on load balancer task, and you might have seen my previous lecture, so which are covering classic load balancer and application load balancer. And this time we will talk about network load balancer. So as you can see, I am on AWS console, and if you scroll to the EC2 services, you can see under load balancer. I'll show you once you go to EC2. Just scroll down, and to your left side you can see under load balancing, it's a load balancer. So here this is the button from where we can launch the load balancers. So if you click, so right now I do not have any load balancer for Mumbai region. Okay, if you click on this button, you can see these are the various types, so we can choose the types as per our the requirement. And as we discussed last time, classic load balancer is something that is going to be stopped working, or Amazon is going to stop servicing classic load balancer after few days. Okay, so please take a note of this. So there is a note for this whatever we are going to discuss. Okay, so basically just to refresh, what is the load balancing? As we can see, elastic load balancing, which is also called as EMD, that automatically distributes the incoming traffic across multiple targets. So the target might be, it can be EC2 instances or containers or IP addresses, and that can be in one or more availability zones. Again, if you are not sure about availability zone, just check out my sessions on what is availability zones and what is data center, all those things, so you will get to know. So basically, what is this load balancer? It does, it actually monitors the health of its registered targets and routes traffic only to the healthy targets. So as we had seen last time, say when I stop one of the EC2 instance, so it will start sending the traffic to that particular target, and which are the healthy or which are the targets. So when in target we had selected EC2 instances, and the EC2 instances which are healthy up and running, so the traffic will be served by those EC2 instances that we had seen in the last time. Okay, and even as per this incoming traffic changes, so the scaling of load balancer also gets changed automatically, and it depends upon, if say there is a majority of workload, so it will scale automatically to that. So as we discussed, so the types of load balancer are application load balancer, network load balancer, gateway, and classic load balancer. And this time we are going to talk about network load balancer. So let's see what are the components of network load balancer and how it differs from the other types. Basically, the main types of network load balancer are load balancer itself, listeners, and target group. So basically, a load balancer, it serves as a single point of contact for the clients. So say whenever there is a load or there is a traffic, so the load balancer, that is itself is responsible for balancing or distributing the incoming traffic to the multiple targets such as EC2 instances, etc. And we can add one or more listeners. So in listeners, if you remember, using listeners, we can add some rules, some ports. So we can use like port 80 or 80 for HTTP traffic, 443 for HTTPS, etc. that we can do using this listener. And what is the mainly listener does is it checks for the connection request from the client, and using the protocol. Say we use HTTP protocol, HTTPS, etc. and the port that we have configured. That is the main task of the listener. And the target group, you can see it's just a collection of these devices, or say in this case, so we can add multiple EC2 instances or containers or IP addresses in a target group, and that will be served as a end destination. So the health checks are performed on all targets registered to target group that is specified in the listener route for the load balancer that we had seen. Okay. So let me just show you. This is diagram we can refer here. See, this is the incoming data, that is in traffic is coming. It's coming to say network load balancer, and there are, say, in this diagram there are 3 EC2 instances. So you can say this is our target group, and this load is getting balanced or distributed across each EC2 instances. You can see this is here 5442. This is the port it's being used. Say in this case that EC2 instances having an application that is listening on for this port 5442. Okay, so in that case, so basically on each target, in this case what we are going to do is, see, in this case the listener will be listening on this port, and that will be configured accordingly to receive the target. So basically the network load balancer functions at the 4th layer of the open system interconnection, that is OSI model. So if you are aware of OSI model, so there are total 7 layers in the OSI, which are physical, data link, network, transport, session, presentation and application. These are the main layers, and this is the 4th. The network load balancer listens on the 4th layer. So on top we have to count. Okay, so this stands on the 4th layer of this open system OSI model. Then why we are basically using the load balancer, that is network load balancer over other types, is basically this supports, or it is due to its capable of say handling millions of requests per second. So if you are looking for extreme performance, in that case only we can go for the network load balancer. And it attempts to open a TCP connection to the selected target on the port specified in the listener configuration. Say in this example, say the target, or so the traffic is like this. Say this is the streaming data in this case. So based on this destination, there will be listener role which will be configured on this network load balancer, and there will be, so that listener role might have, say, which are the EC2, what is the target group. Say for example, this can be a target group A, just to give an example. So there will be like, which is the target group where the traffic should be routed to, what is the port, say everything will be in the listener, which will be configured, and accordingly traffic will get routed to in that case. Okay, and we can enable an availability zone for load balancer. Elastic load balancing creates a load balancer node in the availability zone. Say here in the diagram we have just one availability zone. Okay, say, but in case say we have multiple availability zones, say this is availability zone 1, availability zone 2, etc. In that case, each zone will have a load balancer node that will be configured in that case. So load balancing node that will be configured, and the task of that will be, it will distribute the traffic across registered target in its availability zone only. So that will be, say in this case, there is, say, another availability zone is also there. In this case, there will be a load balancer node that will get auto created, and it will route the traffic to that availability zone only. Similarly, each individual load balancing node will take care of routing traffic to inside that availability zone only. That is the in that case. And say in case of cross zone load balancing, so yeah, we have not discussed this part so far, but we will be definitely covering what is this cross zone load balancing. In this case, how it works is, say for example here in this case there is a one availability zone, but if we add another availability zone, and the network load balancer will balance the route of traffic to each of this zone. Okay, so that will be cross zone, and each EC2 instance also shares, or will be each EC2 instance will contribute into that. So that is called as cross zone load balancing. So we will discuss in the upcoming session when we talk about auto scaling part in that case. So that is so far. And to increase the fault tolerance of the application, we can add multiple availability zone for load balancer and ensure that each target group has at least one target in each enabled availability zone. So basically, see, if you want to make sure that your application is fault tolerant, so what you will do basically, see in this case, your application is sitting on one availability zone which got 3 EC2 instances only. But what in case this availability zone itself goes down, your application would be fault tolerant, right? It would be available. In that case, what you will do, you can add one more availability zone, 1 or 2, and will ensure your application has the EC2 instances, that those are available in those availability zone as well, so that any of the AZ goes down, your application is still available and it will be serving. That is in case of you want fault tolerant application. And similarly, yeah, in that case what you will do, we can add multiple availability zone, that as we discussed, and ensure each target group has at least one target in each enabled availability zone that we just discussed. So yeah, this is the some of the information for the load balancing. Okay, you can go through this information that I will be just sharing in the comment section here. And we can add and remove the target groups. Say we have multiple target groups, and we can add and remove the targets. Say for example, in this case, say there are the 3 targets or 3 EC2 instances in a, say for example, this is target group 1A, and in this case, say my first EC2 instance goes down, so we can remove it, okay, and we can replace it. In this case, there won't be any effect or any performance impact on the application, so it will still serve the traffic to other EC2 instances, unless it, and in the meanwhile what load balancer, it will keep checking whether, say if I stop this EC2 instance, EC2 is the first one, it will just try to, based on again the listener configuration, we will define there, okay, after how many seconds or how many interval it should check whether this EC2 instance is available or not, and it will mark it as unhealthy, and then it will stop the serving or sending the data or traffic to this EC2 instance. In this case, there won't be any impact to the application, okay, and it will serve as regular unless there will be another EC2 instance that will be created. So this can be created using EC2 auto scaling, that is another service which is available in Amazon, so that we can discuss in the upcoming sessions post this. So these are some of the information regarding the overview of the network load balancer. Now you will think, okay, why we should go for the network load balancer instead of classic load balancer. As we know, the classic load balancer is very basic. If you are looking for cost effective solution, then classic load balancer is the best. And if we go up or upgrade from classic to application, so application load balancer or say network load balancer, so there will be a cost associated with that, it will be costly, but there are benefits as well. When you go for or upgrade to network load balancer, there are a bunch of benefit that it comes with that. The first of all, there is ability to handle volatile workload and scale to millions of requests per second. So the very first benefit of using or upgrading to network load balancer is extreme performance. So with network load balancer, you can ensure you are going to get extreme performance with that. Okay. Another benefit of using that is it supports the support for static IP addresses for the load balancer. We can also assign one elastic IP address per subnet enabled for the load balancer. If you have gone through this classic load balancer configuration, so that is not possible in the your classic load balancer. But with network load balancer, it supports static or elastic IP addresses, and that can be used with network load balancer. Another thing is it also supports for registering targets by IP addresses, including targets outside VPC of the load balancer. This is very important. Say when we consider so far the load balancer, the traffic can be routed, it was limited only to that VPC, that is virtual private cloud. But with network load balancer, even say we have one EC2 instance which is outside the VPC, even that can be added as a target, a recipient or destination to receive this traffic. That is one of the major benefit of using network load balancer. Then another, that is next benefit of using this network load balancer, it supports for routing requests to multiple applications on a single EC2 instance, and we can register each instance or IP address with the same target using multiple ports. Say an example, say in this diagram, say instead of this, say if this EC2 instance is serving multiple applications, okay, in that case what we can do, each application might be using different ports. Say for example, there's Apache application is running, okay, then some different applications, say some network applications running on that, and each application might be using different ports. Say for example, just to give an example, one application could use 1500 as a port, another can use 1562, or another can use 8600 as a port, which runs on the single EC2 instance. Even in that case, this support, that is network load balancer, supports requests to multiple applications on the single EC2 instance, and we can register each instance or IP address with the same target group. Okay, so that you can do. So we can register each instance or EC2 instance or IP address with same target group using multiple ports. Different ports can be used as depending on the application, and that can be used in the network load balancer. The next major benefit of using this is it supports containerized applications. So you know that there's Amazon has its own this ECS, that is cluster container service, is available in the Amazon, and using this we can, instead of this EC2 instance, we can also use containers or IP addresses as a target recipient. So that can be benefit of network load balancer. And the next benefit of this using network load balancer is it supports for monitoring the health of each service independently, as health checks are defined at the target group level, and many Amazon CloudWatch metrics are reported at the target group level. So there is also, this one is very important feature or benefit of using NLB. It supports for monitoring of the health check of each service independently. Okay, this is another benefit of using network load balancer. So friends, please let me know if you have any queries. Please go through this and you will understand. So this was just a theoretical part, because this will cost us, this will be outside of the free tier and it will cost you. Hence, that's the reason I didn't cover the demo part of that. But you can go through my previous session where I had covered this demonstration part as well. So please, let me know your comments on how did you find it. I hope you find it interesting. Please like, share, comment and subscribe to my channel, friends, because the videos like this take some efforts. So if you like it, and share and comment and subscribe, so it will be highly appreciated. And thank you so much. I wish you all a very happy learning. Okay, thank you. Bye bye. Hello there, friends. Friends, I hope you all are doing wonderful. As we all know, today is 2nd October and this is Gandhi Jayanti. So we all are celebrating Gandhi Jayanti today, and every Indian is proud of this day. So I wish you all a very happy Gandhi Jayanti first of all before starting this session. Friends, today is a demo lecture. Actually, I am going to create a classic load balancer for you, and will show you the different things by stopping the instances and other things. And before starting this session, I would recommend you all, if you have not checked out my previous video on load balancer theory, so please go and check out that video, so you will get to understand what is basically a load balancer, how it works, and what are the different types of that. So today's agenda, I'll show you some of the steps that I have listed down. So the steps that I am going to carry out as part of this is, so basically we all know, right, the load balancer there are 3 types of load balancer basically. One is classic load balancer, then application load balancer, and network load balancer. Today's session is focusing on what is classic load balancer and how it can be used. So some of the steps of this in order to create the load balancer is, first of all, I will create 2 EC2 instances in separate availability zone with a bootstrap script. So basically this script I am going to actually make it available in the comment section. So this script will ensure, or it will make this install an HTTP, that a service on our web server, so that it will, like, server can be turned as a web server. I'll show you that script before we can start on that. Once this is done, I'll validate the script. So we will install the script on both these servers, and we will validate whether the script is working and whether our servers are turned into web servers. That is the second thing. After this, the third step that I will be doing is I will create a basic, that is classic load balancer, and I will configure the load balancer to use these our newly created EC2 instances, and will configure the listener rules. What are the listener rules? We'll see. Once this is done, the next step would be to verify. So see, before our instances can be used or be part of classic load balancer, so it will in the beginning it will show as a out of service, and once our instances are ready for the load balancing, so it will show as in service. Okay, so we need to ensure that its in service is enabled. We'll see how it will be there. Then the following step would be to so basically when the load balancer is created, so there is no IP address, like it's by default there is no IP address that gets assigned, and it will be a DNS name. So the DNS name will copy and see whether the traffic is getting scattered between both the EC2 instances. And then we will do some more experiment, like we'll just try to stop one of the EC2 instance and we'll see whether traffic is getting still balanced or it goes to the only one of those instance which is live or healthy. And then further I will also try to delete that load balancing rule and see how it is impacting to the load balancer. And finally we will just terminate our EC2 instances and then delete our load balancer. So these are some of the steps, and since it will be out of free service tier, so if you are just not sure or if you don't want to incur the more cost, then you can just see my demo lecture. Otherwise you can just do this step by step procedure and you will get to know. Okay, so I already logged into my AWS EC2 AWS console, and I'm on this EC2 dashboard. So first of all, as per the step 1, I will just try to launch 2 EC2 instances. You can click on free tier only, and this is, I will choose Amazon Linux to AMI, this one, for both these instances. We need to create 2 EC2 instances in each availability zone. Yeah, I'll choose this T2 micro, which is free tier available. We'll click on next, that is configure. So configure EC2 instances. In that we will continue with the default, that is default VPC. You can see this is the default VPC, and for the availability zone, let's choose 1A. So each EC2 instance can be in the different availability zone. Now this is in the AP South 1A. You can see the region that I have selected is Mumbai region. You can select other region as well, it is not a problem. Okay, then scroll down, nothing needs to be modified here, and at the end you will see in the under advanced details you will see a user data. This is basically a script that I was talking about. So I will use this bootstrap script, this one. Just copy it and I'll let you know what is it basically. So so what this script will do is basically it will just update whatever this the things are there. Then it will install HTTP first, and the next step, that is service HTTP start. This step will start the HTTP service for us. First of all it will install, then update it, and chk config HTTPD on. This is responsible if say machine get restarted or if we start the machine, this service chk config HTTPD on will ensure that service is enabled when the machine gets rebooted. Finally we will just make, we will just echo this, like this is web server, so that in the index.html this message will be there recorded that this is web server 1. So we will get to know whether this is just for testing purpose. So we will get to know whether this is first web server, second web server. This is just for a load balancing rule. Okay. Then click on next. Then I'll just click next. Add tag. We can name it as name. We can give it as a web server 1. Click next. Here I will just select this existing security group. So basically you can see this security, you can also try to create a new security group, that is not a problem. Basically this security group has three rules. So I had added by default it was SSH, then I added HTTP and HTTPS on internet. Okay, so this is the by default tool that I had added. I click on next to review. This is just basic a summary. Everything is okay. I will just directly click on create and I will use existing key pair. So my first instance is just getting launched. Okay, you can see here instance is getting launched now. This is our first instance. Okay, now until this gets available, I will create another instance since we need two instances, right? So let's select the same again, Amazon Linux to MI. Quickly let's go through that. So this is just these the steps are we are just repeating. Here again default VPC, and this time I will select AP South 1B, that is different availability zone now in this case. Again if you go down metadata, we will just paste that bootstrap script, and here what I will change in the echo section is this is second web server. Okay, I'll just click on next. Then the storage you can as by default you can put add tag and make it as web server 02. Basically I will make it as and click on next to configure the security group. Again in this section we will use the default security groups, and if you want you can create a new security group, that is not a problem. I'll click on existing one that I had created previously. This is the same that we use for the previous instance as well. This got SSH, HTTP and HTTPS. Okay, click on next, launch button, and I'll click on launch. And this is the key pair. So please remember, like for this demo lecture we are not going to log into EC2 instance. So you can use whatever this existing key pair you have. Now our second instance is also getting launched. So this is our first EC2 instance, and this is another is just getting launched. Now let's see whether the bootstrap script is validating or it's working or not. For that one I'll just simply copy this public IP address, go to my web browser and just paste it here, and let's see. You can see this is the first web server. Now similarly let's wait for our second web server. Yeah, the checks are passed for that as well. I will again validate the functionality of bootstrap script. Again copy this public IP address, go to the web browser and paste it. The same way we did for the first EC2 instance. Yeah, you can see it now. This is showing that this is the second web server, this is the first web server. Okay, so our bootstrap script is successfully installed. That is the meaning of this one. Now the next step is, as per our steps, we created two EC2 instances, then validated the bootstrap kit. Now the next step is to create a classic load balancer. For that, this is available under the same section, that is EC2 section. If you scroll down, you will find it here. Under load balancer, there is a button known as load balancer. Click onto that and click this button, create a load balancer. So you can see here basically application load balancer, network load balancer, gateway load balancer, and after this it is a classic load balancer. This is actually a previous load balancer. This is previous generation, you can see, and soon this will be out of date. Like after few days, it depends upon AWS. So you can see here, AWS will be retiring EC2 classic network, that is load balancer of 15th August 2022. Okay. So this is officially, it will be retired. After some time it won't be available. Okay, so because this is basically dumb or very basic load balancer, so that is the reason. I'll just click on create. Here let's give it a meaningful name, something like say LB01. You can give any name. So there are few options here. Create load balancer inside here. So this is default VPC. So it's by default there. If we have other VPCs, it will show here. If I don't have other VPC, it's not the option here. Create an internal load balancer. This is basically, see, if our architecture or it's defined in such a way that it needs to be defined inside. So in that case, we can use this internal load balancer. Since in our case, this will be into internet facing or public web facing. So that is not an internal load balancer. That is whatever we are going to do, or will be external or public load balancer. Okay. If you need more detail, you can just click on this button and it will give you what is this more detail of what is internal load balancer. Then again, enable advanced VPC configuration. Let's try to see what is the option here. So basically, you can see this option will allow us to choose the subnets. Basically, you can see here it is asking us, please select at least 2 subnets in different availability zone to provide higher availability of for your load balancer. So as I earlier mentioned, we need minimum 2 availability zone, 2 subnet in different availability zone before we can add. If it is the same subnet, then it won't allow us to use this load balancing feature. Okay. For now, I will just not use this advanced configuration. And listener configuration, this is basically, they are the protocols, like which protocol we want. We can choose these much protocol: HTTP, HTTPS, TCP and SSL. These are the 4 protocols. We can use either of these as a listener configuration. This is basically port where we want our traffic to be received on our EC2 instances. That is basically the meaning of this one. I'll go with HTTP, then the port number for HTTP is 80. Again, the instance protocol is same and instance port. Okay, this is, I'll click on next. Assign security group. Again, load balancer also needs security group, so I can choose the same one, that is the same as our EC2 instance. This is the launch wizard. I'll just continue the same. Click on next. Then I'll click on next. Basically, this is a kind of warning. It's not secure here, but since we will delete it as soon as it's completed, hence I will just click on next one. Now this section is very important. This is to configure the health checks. This will talk or explain how we want our health check to be performed. Say our EC2 instances, you can see here the ping path, we can give it as index.html, which has our that content, right? If you remember, our bootstrap script contains this data. This is first web server and this is second web server. So this is the index.html. We can give any message inside that. And the next section here is advanced detail. Here there is a small button, you can see. The first one is response timeout, time to wait when receiving a response from the health check. So it is 2 seconds to 60 seconds. 2 seconds is minimum, 60 seconds is maximum. So I will go with the 2 seconds, the response timeout. Then again for the interval, it's amount of time between the health checks, like how soon we want the health checks to be performed. So by default it is 5 seconds to 300 seconds. So for this demo lecture I will just choose the 5 seconds only. Then unhealthy threshold and healthy threshold. Basically, if these are the counters. Say, for example, there are two EC2 instances that we are going to use, and out of those, one has been stopped or it's not available. So, load balancer will be based on this count. If we specify as 2 as a you can say minimum is 2 and maximum is 10. If that is the 2, then health check will load balancer will try to reach is 2 times. And if still after second attempt is not responding, it will mark that EC2 instance as unhealthy and it will be out of service. That I will show you how it will be there. And similarly to the healthy threshold. So out of this, you can see again the counter is same. So if for 3 times it will check for 3 times before making as a healthy. So these are basically counters you can see. And based on this counter, it will decide whether it should be marked. It will, load balancer should send traffic to that, or it should exclude based on these parameters. Let's go to the next section. Here you can see our both EC2 instances are launched. Since that is the VPC that we had selected, I will select both. Both are, you can see the state are running, and yeah. Then I will click on next. I will give again the name as say any name you can use, ELB, something like that, and click on last page. This is basically a new page, and I will click on the, so this page is showing it has been completed. Now the health check that I was talking about, you can see here the status right now is showing as out of service for both EC2 instances. So this means these instances are just being added to this load balancer. Those are not yet available for the load balancing. And once those are available, it will show as in service when those instances are available to take the traffic. So there are various sections like health check. This is we can edit health check, listener, monitoring, tag, and all those things are here. We can say using this migration we can migrate this classic load balancer to the next generation, which is application load balancer or others. We can migrate using this wizard. So let's wait for a few more minutes. Here you can see both services status is now has been changed from out of service to in service, and there's a button as well. You can see here. Yeah, for some reason it's not showing here, but basically this will show why what is the reason for it's available or not. And if you go down, you can see the healthy, the status as the count and healthy. So based on our health check configuration, this has been decided that it's a healthy. And for this availability zone, that last one, since there nothing is there, means it's not relevant, and for now it is showing as healthy as no. But we can ignore it because we haven't considered or not added to the load balancing. Okay. So now if I go to my description, this is the DNS name. So there will be always a DNS name for load balancer. It won't give a IP address ever. You just copy it, go to my web browser and paste it here and enter. Now you can see, if I just try to refresh it, you can see it's giving it as a first web server and second web server. So the traffic is getting balanced between two. It's going to the both instances one by one. You can see it's randomly. It's first of all it's first, second. It's the way it's balancing the traffic. So if we had 3 EC2 instances, then it will try to show first web server, second web server, third web server. One by one it will go and the traffic will be balanced across the 3. Okay. So it means our load balancer, classic load balancer, is functioning as it's designed or as it is expected. Now the next step is we can stop one of the EC2 instance, see its impact on load balancer. Okay, let's try to stop one of the EC2 instance and see how it will be. Yeah, just before that, please note here, see the EC2 instances section. Right now web server 1 is showing as in service. Both these instances are showing because those are healthy. The healthy section is here, and yeah, and once we stop it will show as out of service. Okay, that you can notice now. I'll go to EC2 dashboard, instances. Yeah, and let's try to stop web server 1 for now. I'll select it, go to instance state and try to click on this button, that is stop is instance. For the confirmation it is stop is. So my first web server has been stopped, and only, yeah, this is getting, it is stopping. Yeah. You can see it stopped now. If we go back to our load balancers now, see, you will notice here immediately this has marked web server 1 as out of service since we had stopped it. And again, in this section below it will show it's healthy, it's showing as no, because that has been stopped, means load balancer is not able to reach it. And for doing this, what in the background it has done is, if you remember these rules, listener rules, it will mark, it will try to reach it twice before it is marking as unhealthy. Okay, so that is the thing here. So if I go to my load balancer's DNS name, now you can see it's just going to second web server only. It's not even going to the first web server, because first web server is not at all available. Means for now the traffic is just getting routed to second web server only. It's not going at all to first one, since first is not available. And in case we start it again, if we go back and say, for example, I will stop, I say I'll start it once again. Let's give it 2 or 3 minutes before the status check is checks passed. There are 2 checks, as we all know: system status check and instance status check. Before a status will be turned as checks passed. Now right now it's initializing. Okay, let's refresh. It's still initializing phase. Yeah, meanwhile, let's go back to load balancer and see. You will need to notice here, it will now showing again as in service. Okay, so it will automatically detect whether the instance is available and running or whether it is stopped, and based on that it will check the status. So it is finally in service. Now if we again try to reach the instance, now you can see it again started to routing traffic to first web server and second web server, since both are available. Okay, now let's do another thing. Let's go again to the load balancer. I'll go to the listener role. see how our load balancer behaves now. Now since it's not able to find anything, since the rules are new, so whenever there are no rules associated with listener or load balancer, then that load balancer is of no use. Okay, you can see here. So it's not able to reach it. Okay. So when we remove the load balancing rule, that load balancer becomes inefficient. And in order to start it, we need to again edit and add these rules. That is the output of this one. So now since this is done, finally what I will do is just terminate both EC2 instances. Web servers and we directly terminate those. Okay. You can terminate. So this has terminated it. Then I will go to my load balancer again. Select and go to action and click on delete button. Yes, so it has been deleted. So friends, I hope you got the idea. Basically, a classic load balancer is very basic kind of load balancer. It is just simply intended to balance the traffic which are across available EC2 instances which are part of that, and it will balance it. So if you want additional or advanced load balancing, we can migrate it to the application or classic or load balancer, and those got some extra smartness or extra features that will help us. So the features like if you want to balance the weight, let's say we want to balance it like instead of 50-50, if we want to like 30%, 70% to be weight based or regional based or latency based. There are lots of features that other load balancers offers as compared to the classic load balancer. And again, as I have discussed during this session, so a classic load balancer will not be available after a few days. It's getting obsolete and it's already end of support by AWS. So friends, that's it for today. I hope you enjoyed this lecture. Please don't forget to like, comment, share and subscribe to my YouTube channel, because serious sessions like this takes effort, and I highly appreciate your support for this one. Thank you so much, and stay tuned. Enjoy. Bye-bye. Hello there, welcome back to my YouTube channel. You all are having a good time, right? So friends, in the last session we had seen a demo lecture on classic load balancer, and today is the time we will see about theory or the demonstration part of the application load balancer. I'll just quickly walk you what are the steps that I will be carrying out during this session. So you can see there are some of the steps that I have listed out. First of all, we need to create two EC2 instances in the separate availability zone with the bootstrap script. If you remember, like bootstrap script is to enable it as a web server. Then we will validate whether our bootstrap script is working. Then after this we will create a target group. So basically here the target group we will use in the application load balancer, because this is kind of this will group our EC2 instance, and all this traffic will be routed to this traffic target group instead of going to individual EC2 instances. That is the difference here. Then we need to ensure these EC2 instances are registered as add to registered. That is an additional step that we need to carry out. We will see how it will be carried out. And next, after this step, we will go and start with our application load balancer creation using the same target group that we have created in the step 3. Once this is done, we will see, we need to wait for some time. Like once we have created our application load balancer, it will initially reflect as provisioning state, and it will take 1 or 2 minutes depending upon the bandwidth. So it will change to the active state. So this is the state we need to wait until we can start using our application load balancer. Then after this step, we need to again wait for our all the instances should show from initial to the registered set, so that we can say like it started using, like load balancer will start recognizing these are the EC2 instances, those are healthy and can be used. And after this step, we will copy the DNS name. If you know, like the AWS load balancers won't be having any IP addresses, but there will be a DNS name that will be associated with the same. Then we will explore what are the some intelligent routing rules, and finally we will go with the deletion of the resources. So the main difference between classic load balancer and application load balancer is, once application load balancer is created, I will show you there are some of the rules, like routing rule. It enables us so that we can add some conditional rule, if, then, some, forwarding to the next loop, etc. So there are some of the intelligent rules that it provides. Hence, it is known as the application load balancer. And the main intention or main use case for using application load balancer is when we are expecting some intelligent routing, some decision making at the load balancer end. We will go with the application load balancer. Okay, let's continue the demo. Here you can see we just continued with our web servers that we had created in the earlier step. So I would recommend you to please check out my last video on classic load balancer before performing these steps. And here I will just validate whether say bootstrap crypt. I just quickly see bootstrap crypt already enabled and it's working on both these servers successfully. So now the next step is, let's go to target groups. So basically it's a collection, or you can say a unit of instances, so that the traffic can be routed. I click on create target group. Here there are several options, so we can enable, like the target type can be instance based or IP addresses, lambda function, or application load balancer. Okay, so here since we are going to use with the EC2 instances, I will just keep the default one, which is instances. Let me give it as name as my ALB1. Protocol, I'll keep it as the same, and this is the default VPC that I am going to use. Okay, there is no separate VPC that I have customized for this one. Moving to the next point, it's health check protocol HTTP, and here health check path I will use the index.html. Click on advanced health check setting. Here it allows some other options. Healthy thresholds, I will keep it as 2. This is basically, you can see here there's a little bit description here, the number of consecutive health check successes required before considering an unhealthy target. So basically these are the threshold. It will check before ensuring this EC2, or before marking that particular EC2 instance as unhealthy. So it's twice it will check. Similarly, for unhealthy, let's keep it as 3. And timeout, this is the amount of time in seconds during which no response means a failed health check. Okay. Again, I'll keep it as 2. Let's keep as minimum values. And the interval, which is the approximate amount of time between health checks of individual target. I'll put it again as 5. And this is HTTP code. This is default. This is 200. I won't touch it. In the tags, let me give it as a name, something like name and value pair. Basically, this is a key value pair. Name as my ALB. Okay, and I will click on the next button. Now Now about available EC2 instances, these are our EC2 instances that we have already launched, and just select both and click on include as pending below. This is the step where we need to ensure those are registered, okay, and I will just click on create target. So when this is created, you can see here so yeah, these are showing as unused because we have not created our load balancer yet. That is the reason it's showing as unused for now. In here you can see the target group is not configured to receive traffic from load balancer. Once it is done, then it will show as used, and after this step you need to again select both these and click on register target. Yeah, so this step is also done, so we are good now. Now let's go back to EC2 install section, and I will start with the creation of the load balancers. So go to load balancers, create load balancer, and as you can see here, the classic load balancer is a previous generation. So after few days it will get deleted from AWS and it won't be longer available. For now we have application load balancer, network load balancer and gateway load balancer. These are the main types. For this demo lecture I will refer, or I will go with the application load balancer. So I will click on create button here. So here let's first of all give some names. Now here will be something like that. You can give any name. Let's say here will be, and these are the schemes. It's internet facing and internal. So as we have seen, we discussed last time, internet is facing is basically, this is a load balancer where the clients, like directly over the internet the traffic is received to those targets. So targets is the EC2 instances in our case. And there is another type is internal, which is as per design we can ensure this load balancer is in between the architecture. So that will use private IP addresses. In our case, this is going to use public IP addresses since it will come from internet. However, for internal one, it will use public private IP address. Then IPv4 IP address type, I'll just go with the default. It is IPv4. You can see the VPC is default VPC, and for the mapping, I will select all these are the availability zones. Basically, I'll select each of these. So there are 3 availability zones for Mumbai region, since I selected all the 3. About security groups, I can go with the existing security group that we have created last time. All good. Let me go to this listener and routing. Here you can see the listener, it's HTTP 80, and under target group I'll click on target group, and this is the target group that we have created in the last step. So once this is done, all other things are optional. This is optional. You can see here tag and other services. So we are good, and I will click on the create load balancer. So you can see once we have clicked on create load balancer, initially this will be in the provisioning state, and we need to wait until it turns to the active state. You can see this step here, we are at this step. We have performed the previous steps. We are at the step 5. the state should change from provisioning to active state. So let's wait. It takes 2 or 3 minutes hardly, depending upon the bandwidth. So meanwhile we can explore the other options. See, this is one that I was talking about. The way it differs, or it's different from classic load balancer is, this application load balancer has some advanced rules. You can see there are some customized rules. If I click on view or edit rules, so these are the rules, like if then. So there are several things, we can add customized rule. Say if I click on insert rule, so based on condition, say these are the several things like host header, path, HTTP header, HTTP request method, query string, source IP. It provides a lot of options so that we can configure, or intelligent routing can be made using this application load balancer. So for now I am not going to go this deep, so I'll just cancel it and go back. So you can see the state has been changed from provisioning to active state now. Okay, let me see the monitoring and other things. So everything is okay. Since we now added the tag, I can add it now. Again, it's a key value pair, we can give any name. So for example, department, I can give it as IT, something like that. You can give up to 50 tags, you can give in the AWS. Okay, and now I go to description, and this is the DNS name. So every load balancer will have its DNS name, it's not the IP. So remember this fact. Okay, I'll just copy it here and post in my browser. Click enter. So first time it will take few seconds. So yeah, you can see here. So now the load balancer has recognized like the EC2 instances which are added to its backend, and now you can see if I just randomly refresh it. So it's going to first web server, second web server. So these are basically our EC2 instances. So the traffic is getting routed to each of these. And in case say I want, as I was mentioning, if I need to make some changes, I will simply go to this view or edit rules, and we can add or customize several things here so that it can take some intelligent decision making. And this is not applicable in case of classic. So classic load balancer is very simple and cost effective, but if you are looking for say some advanced routing rules and other things, then the application load balancer is something that you should go for. That is the thing. And please ensure once you are done with this demo or exploring the things, just ensure you are deleting your resources, otherwise it will cost you some money. Okay? So please ensure that. So friends, that's it for today. I hope you got the point. So basically we will go for application load balancer in case of intelligent routing, and for classic load balancer if you are looking for very basic and some cost effective solution, and network load balancer is something when the extreme performance is expected. So these are the some types of the load balancers. We will see, we'll talk about the other features of load balancing in the upcoming session. So please like, share, comment and subscribe friends. I hope you will understand videos like this take some effort, so we'll appreciate your support.